We throw around this term AI learning all the time, but what does that actually mean? I mean, a machine doesn't have a brain, right? It only gets numbers. So how on earth do you teach something that only understands zeros and ones to do something amazing, like recognize a photo or predict the stock market? Okay, let's really dive into this. That is the central mystery, isn't it? How do you bridge that gap? Well, let's open up that black box together and look at the two most fundamental ways we teach machines to make sense of our world. I promise, by the end of this, it's all going to click.
All right, so let's start with the most common method, the one that's kind of like studying for a test. It's all about having a guide, a teacher, or in this case, a really good answer key.
This is what we call supervised learning. And honestly, the absolute best way to think about it is to just go back to how you might have studied in school. With flashcards, you've got the question on the front, and crucially, you've got the correct answer on the back. This quote just nails it, doesn't it? It makes the whole thing feel so intuitive. The process is exactly the same as how our brains learn. You see something, you take a guess, you check if you were right, and if you were wrong, you adjust for next time. A computer just does this millions and millions of times way faster than we ever could. So here's how that really works in practice for the machine. First, it sees a piece of data. Let's say it's a picture. That's the front of the flashcard. Step 2, it makes a prediction, a guess. Okay, I think this is an apple. Then, step 3, it gets to check the label that a human already provided. It flips the card over. The label might say, yep, that's an apple. Awesome. Or it could say, nope, that's an orange. The algorithm then calculates how wrong it was and makes a tiny mathematical tweak to its internal logic so it's just a little bit better next time. And then it just does that again and again and again, millions of times.
A perfect real-world example of this is your email spam filter. You see it every single day. Engineers feed the AI millions of emails, but every single one has a label attached to it. This one is spam, this one is not spam. Over time, the AI starts to pick up on the patterns, like, hey, emails with words like lottery or URGNT in all caps, they're almost always labeled spam.
So you can see that supervised learning is incredibly powerful, but it has a really big catch. It completely depends on a human teacher to create that answer key in the first place. It's super accurate, but it can be really expensive and it takes a ton of time. So what happens when you don't have an answer key? Well, that brings us to the other side of the coin. This is a much more mysterious and honestly fascinating approach. This is for when you just have a massive, messy pile of data, and you basically want the machine to explore it without any instructions at all. This is called unsupervised learning. And if supervised learning was like studying with flashcards, this is like giving a toddler a giant box of mixed-up Lego bricks and just saying, go figure it out. There's no right answer, no instruction manual, no picture on the box to follow, just the bricks themselves. At first, it's just chaos, a massive mountain of raw, unlabeled information. The AI has no idea what any of it is or what it's even supposed to be looking for. So what does it do? Well, just like that toddler with the Legos might start putting all the red bricks in one pile and all the blue ones in another, the AI starts looking for similarities. It's searching for data points that are mathematically close to each other in some way. And eventually, almost like magic, patterns begin to emerge. That once messy pile of data starts to organize itself into these distinct clusters or groups. And the amazing thing is, it does this all by itself, discovering these hidden structures that a person might have never ever seen. The perfect example, recommendation engines on places like Netflix or Spotify. The algorithm doesn't know why you like sci-fi movies. It has no idea. It just notices that your viewing habits are mathematically very similar to a whole bunch of other users. So when someone else in your cluster watches a new sci-fi movie and loves it, the system automatically recommends it to you, just assuming you'll probably like it too. It found the group of sci-fi fans without any labels. Okay, so let's put these two powerful ideas side by side to really make the difference crystal clear. It all comes back to our main analogy, studying with flashcards versus sorting a giant pile of Lego bricks. So it really just boils down to this. Supervised learning starts with clean, labeled data because your goal is to predict a specific outcome. You already know what you're looking for. Unsupervised learning, on the other hand, starts with raw, unlabeled data, and its goal is to discover hidden patterns you might not have even known were there. One is about prediction, the other is all about discovery.
So why is understanding this difference so important, especially right now? Well, it has everything to do with the just unbelievable scale of information in our modern world.
And just look at the scale of this challenge.
We are creating data at a rate that is just mind-boggling. But less than 1% of all that data is neatly organized and labeled for a machine to study. That gap is absolutely staggering.
And this right here gets to the absolute heart of the challenge. There simply aren't enough people or enough hours in the day to create flashcards for all the data that exists. Our ability to label data has become a massive bottleneck. And this is exactly why the ability for AI to learn on its own, to discover patterns in that giant pile of unlabeled Legos, is becoming one of the most critical frontiers in all of technology. It's about unleashing AI on that other 99% of data that humanity has never really systematically explored.
And that leaves us with a really fascinating final question to think about. As these unsupervised models get more and more powerful, they're going to be sifting through data that no human has ever organized or analyzed. So what hidden patterns about our world, our biology, or maybe even the universe itself are they going to discover that we have completely overlooked this whole time?